Well, welcome to today's lesson, which is a continuation of lesson 2.3. We're going to be writing quadratic equations. So today's goal, we're going to write equations of quadratic functions using vertices or vertexes, points, and x-intercepts. So to start off, we're going to talk about vertex form. If you remember, a vertex form has some a in front that'll either shrink it or stretch it or make it open down. We've got x minus h squared plus k, where h and k is your vertex. So in example 1, we are going to be talking about someone shooting out of a cannon. So we've got the circus coming up, I know, end of September. So example 1 shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. And we know the performer is going to land in a net that is 90 feet from the cannon. But what we're trying to figure out is how high the net has to be. So it is important that we get the right height of the net, otherwise that performer could get very injured. So let's look at this problem. So again, I know the height of the net is somewhere over here. It's roughly above 20. We could probably take a guess. But I don't know where, and again, we need to know exactly where so that performer does not get injured. So I know the net is 90 feet away. I just don't know how high. So step 1, we need to write an equation in vertex form, since we know the vertex, that can help us figure out this problem. And so let's make sure to use our equation that they gave us right up here. So I'm going to start with y equals a. My problem is going to have an a because I don't know what my a is yet. I do know my vertex, so it'll be parentheses x, and 50 is my vertex, so when it goes in the equation, remember it's going to be the opposite, so negative 50. Don't forget your squared. And then we've got plus 35 for our k value. So step 1, if you know the vertex, you can write an equation in vertex form. Now, I need to figure out what my a value is next. Now you can use any point. They give us a nice point. They give us the y-intercept. So I'm going to use the y-intercept to find your a value. Now if you'll remember, your y-intercept is 0, 15, and x is going to represent a 0, or 0 is going to represent x, and then 15 is going to represent your y. So I'm going to take these two numbers and plug them into my equation and substitute them. So 15 is going to go first before the equal sign, because that is my y value. Again, I don't know my a. Parentheses, I do know my x value is a 0. And then minus 50 squared, yada, 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 the rest of my equation. Okay, so after you have an equation in vertex form, you can use the y-intercept or any point to substitute it in and solve for a. So I'm going to use my order of operations to solve this equation. So parentheses come first. I can simplify what is in parentheses. 0 minus 50 is negative 50 squared. So everything is going to drop down, except in parentheses, I have negative 50 squared. After parentheses comes exponents, and so I need to figure out what negative 50 squared is. Negative 50 times negative 50 is 2,500. And so again, 15 will come down, 35 will come down, and in math, they like to put the number in front, so then the a just kind of switches behind. So now I have a two-step equation where I want to solve for a. So I'm going to move this 35 over to the left side by subtracting 35 on both sides. 35s will cancel. 15 minus 35 is negative 20. And then go ahead and drop down that 2,500a. Our last step is to solve for a. So we want to divide by 2,500 on both sides. And we are going to get a small number. It ends up being negative 0.008. So that is our a value. Number 1, it makes sense because it's negative and my graph is opening down. This graph is also very wide, and so it makes sense that this number would be less than 1. Okay. So I now did all that work to find my A value. But again, the question says what is the height of the net? So I'm trying to figure out how high this net is. I'm going to take this A value and substitute it into the front, so I have an official equation. So my official equation of this human cannonball problem was my y equals my A value, so negative 0.008, and then I just brought everything down with my vertex and vertex. So now that I have an official equation, and I know that my net is 90 feet away, and 90 represents an x value, I can take 90 and plug it into my equation. So I would have negative 0.008. Plug in 90 minus 50 squared plus 35. And then I can type all of this in the calculator, and that will tell you a number of how high the net is. So after typing it all in, we get 22.2 feet. So that is where the height that my net should be. So our cannon person does not get injured. So a lot of work for writing the equation of a quadratic, for sure. So if you have any questions, let me know. You can press pause, ask for some help, or ask any clarifying questions. We're going to move on to part A. So part A says, what is the average rate of change in distance over the interval in which the height is increasing? So if I look at my graph, it is increasing on the left side between the y-intercept all the way to the vertex. And so if you'll remember, the interval means between, and in math, when we write between, we've got an x in the middle. And so my x values where it's increasing started at a 0, went all the way to 50. And so that is the interval for which it is increasing. So if I want to find the average rate of change, that's a fancy way of saying the slope. And to find slope, I need 2 points. So my first point is going to be a 0, 15. And then my second point is going to be 50, 35. Now, if you remember the slope formula, you need an x1 and a y1, and an x2 and a y2, and I'm going to find my change in y over change in x. So the formula for slope is y2 minus y1 over x2 minus x1. And so I'm going to be substituting those numbers into my equation. So I'm going to start off with 35 minus 15 on top, and then my x2 would be 50 minus 0. So if I simplify the numerator, I would have 35 minus 15, which gives me 20, 50 minus 0, which gives me 50. So now you can reduce that. You can do a decimal or you can do a fraction, up to you. But that would reduce to 2/5 or 0.4. So totally up to you of what you would want to use. There was nothing there. So the average rate of change, or the average slope, on the left side of our graph is 0.4. It's positive, it's going up, makes sense. So let's talk about the average rate of change for when it is decreasing. So decreasing would mean going down. My graph is decreasing from the vertex all the way until this net that our cannonball person hit, which we knew was at 90 and then 22.2 feet. So again, it was decreasing starting at the vertex of 50 and then going all the way to 90. That would be the interval, technically. So if I'm looking at 2 points, I'm going to be looking at my points of my vertex, 50, 35, and then the point of my net. And so again, same formula that we have above. So press pause and actually see if you can find the average rate of change for this problem on your own. Alright, so remember our slope formula would be y2 minus y1 over x2 minus x1. After substituting in our points, I would get the following. After simplifying the numerator and the denominator, you get the following. And after dividing, you would get negative 0.32. So that is the average rate of change, or the average slope of our problem. It is negative because it is decreasing. So that makes sense. So that is how you find the average rate of change over a certain interval. So make sure you find the 2 points, use your slope formula, and simplify. So let's do one more problem on writing the equation of something in vertex form. So example 2. This one is a little different, no context, just straight up problem. So example 2 says write an equation of the parabola in vertex form that's going to pass through the point 1, negative 7, has a vertex of negative 2, 5. Use x and y for your variables, and we're going to round anything to the nearest fraction. So in our first problem, I used a y-intercept because they gave it to me. But this time they gave me a random point, which is totally fine. But I do need to use this vertex to write an equation first. So remember, you're going to start off with your equation, which is y equals. We're going to put a random a in front because we don't know which way our graph is facing yet. Go ahead and put your vertex. Remember, the vertex is going to be the opposite. So instead of a negative 2, it would be x plus 2. Don't forget your squared. And then your k part of your vertex will be the same, plus 5. So step 1, take your vertex, write it in vertex form. Step 2 is to use this point they gave you, and we are going to plug in our point. So remember, the first one is your x value, the second number is your y value. So I'm going to start with negative 7 on the left because that's my y value, equals my a, don't know, solving for it. My x would be 1, and then continue with the rest of your problem. A common question I get asked is, do you have to change anything when plugging in? No. That is only when you're writing the equation, where you would flip signs. So from here, we are going to solve. Order operations says do parentheses first. So I know 1 plus 2 is 3. And then 3 squared I know is 9. So I kind of did that in one step versus breaking it down into 2 steps. So again, 1 plus 1 is 3. 3 squared would get you a 9. And again, in math, write the number in front. So bring down the 5 and bring down the negative 7. How to solve this? You would subtract 5 on both sides. Negative 7 minus 5 would get you to a negative 12. Drop down this 9 and then divide by 9 on both sides to get us negative 1.3 repeating, or if you hit math enter enter in the calculator, that would give you the fraction negative 4/3. I believe for your assignment it's going to want a simplified fraction, so I would use that math enter enter button to get negative 4/3. So all of that was just to solve for your a value in front. And our question said write an equation. And so I'm going to take this original equation, put negative 4/3 in the front, and then I am done. So our final answer would be y equals negative 4/3 for my a, and then x plus 2 squared plus 5. And that's how you write the equation of something in vertex form. So let me know if you have any questions. This video was the front page of the notes on writing in vertex form. And if you go ahead and watch part 2, that will help you write something in factored form. So thanks for watching. Let me know if you have any questions.